Hey everyone, so today I'm showing how I did this. I did this yesterday and I haven't seen it done before. So if you don't know what to do in Minesweeper, remember this button over here that makes that resets everything? Well, if you press it, physically plays for you. It's like, wow, look at it play. We never had this feature, which is just like play for us, AI play. So how did I do this? So first of all, I looked for a Minesweeper implemented in Python, so something like pygame Minesweeper. I found this one, then I went to the home page, and yeah, so basically I cloned this, and yeah, here it is. I cloned it, and I added some extra files. I found the place where it um, did the game reset. So this is the function that gets called whenever you press on this cute face, and I just replace with some of my own code. And took a little while for me to figure out how to simulate a button press, but after I did, it's basically you do this. So I create an algorithm that gives me what is the position that the AI should play. And as we see over here, so 818, which means row 8, column 18. Yeah, I'm not going to count it right now, but yeah, you get the picture. So how did I do this? So first of all, this playing Minesweeper is a problem that can be solved using integer or linear. Let me just zoom it in so you guys can see. Linear / integer programming. And what is this? Is finding the best combination of solutions finding the best solution given a set of constraints. And if you want to search for this, I wrote some articles on medium.com during the quarantine, and yeah, I did 4 of them. If you go through the first one, it teaches you how to do this with Python, and it explains step by step on how to do it. This uses pulp, and this is what I'm going to use in this video. So let me explain JS Paint. If you don't know how to play Minesweeper, basically what it is let's go and look for example, this square over here, number 1. It means that around the square there is one mine. So, okay, I know this is a mine. Same thing here. I know that around this one there's one mine, and let me get an example. So I know there's a mine here, and I know there's a mine here. But this too says that around this square there's 2 mines, but we already know that these ones are mines, so these ones must not be mines. So this is how it works. So how does linear programming work? In this case, I'm just going to give you a very simple example. Yeah, I'm not so good at this. So let's say we have let me think. Okay, I got it. We have a 1 here. And then we have a 2 here and a 2. And this is also a 1. And these squares over here haven't been open yet. Oh, God. I need to close this. Yeah, let's go to the gray. Yeah, these ones are closed. So this means that if we look at this square over here, we don't know which one it is. If we look at this one, we don't know which one it is too. But we know that this one right here works. So with integer programming, basically you create variables. And let's call this v1. And then you have v2. And what we do now is we know, let's look at this square over here. We know that the sum of all the peripherals are 1, because it's 1 over here. So sum of v1, it's an array, is equal to 1. Same thing for the next one, sum of, it's the same, is equal to 1. Here we know that the sum of v1 and v2 is equal to 2. We also know that the sum of v1 and v2, again, for this over here, is equal to 2. So if we write this, let me show you how I did it. You need to create, where are they? You create a variable, LP variable, that is between 0 and 1 and is an integer, which means v1 and v2 will be either 0 or 1, and no number in between. So this 0 means it's not a mine, 1 means it's a mine. If you add this to the linear programming model and then you ask for it to solve, it will give you a status. And the status is, if it's 1, it means that it found solution. And then it will give you all the variables from that solution. So in this case, v1 is equal to 1 and v2 is equal to 1, and all the conditions are satisfied. So that's what I did. The first part is converted to a format. So basically, let's get back to this. I hacked it and we get the board like this, and it's just a bunch of stuff. We have the tiles, which are objects, but the tiles just give us what we want. This is exactly what we actually want. The number is the value, I and j are the positions. So we convert this into this, which is a map. For each position, it gives us the number. -1 means that it's not open, and then 0, it means that it has nothing, and then you have numbers. So after you have that, you have this perform magic LP. So over here, it just pretty much creates the variables for each of the interesting positions. Why do I say interesting positions? Because if we look, we only care for the positions that are next to numbers. So all these numbers, all these positions over here, these tiles, they're not interesting for us because we can't really guess them. So we need to first go through the ones that are next to the numbers. So that being said, then we have this, the sum of the variables is equal to the number on the tile, which is what I explained over here. Pretty much the same. I added this constraint because I know the number of the mines, but this is actually not necessary. You can even comment this out. And then we solve it. If status is equal to 1, then we're going to come here and get all of the non-mine positions. So actually, we can even do this. Let me just print var. I can print all of this. So you'll see what is the result of linear programming. Look, over here, you get all the positions that we got and the results. So 5 and 11 is not a mine, 5 and 12 is not a mine, 5, 13 is a mine. But so it gives us all the solutions for the variables that we inserted. But we only want one, so we return all the non-mines. And then we just choose one. So I'm gonna stop the breakpoints. So yeah, and this is how it plays. However, there's a problem. Let me try to find a case where it will work. Okay, I'm worse than the AI. Okay, so let's imagine we only had this number 1 here. So we would have all the variables surrounding this number 1, and then we would ask the linear programming, integer programming algorithm to give us a solution. And it will tell us, oh, there's a mine over here, and all the other ones are not mines. Which makes sense. But this is not necessarily true. It satisfies the constraints. It's a valid solution given the constraints, but it is not a 100% sure solution. So how do we do this? So we found a solution. Found solution is a Boolean. Yes, we found a solution, and here are the positions. So for each of the positions, we're going to run the same algorithm again, but we're going to tell the algorithm this. Hey, you know this position that you told me that is not a mine? I'm telling you, I have like a secret someone told me, and they told me this is a mine. So in force position, if this value exists, it's going to tell the algorithm that it is a mine. So just to make sure again, for a non-position, for a non-mine, I'm forcing it to tell me it's a mine. And then it's going to solve, and it might tell me that it's impossible to solve. And what does this mean? And this is the tricky part. If it's not possible to solve, then we found a solution. And we return the solution, and the AI plays for us. See, why do we do this? So let's say that the algorithm tells us to play here. Let's forget about this again, and it tells us to play here on this square. And we're going to tell the algorithm, okay, run just the LP again, the algorithm, but I know that this is a mine. And it will tell me, oh, then play over here. If the algorithm gives me another solution, then it means that this is not 100% sure. This is valid given the constraints, but this is also valid. And we don't want to guess, we want to be sure. So that is why, let's go again. I'm going to play this, and we're going to play, all the way until we reach a point that the algorithm doesn't know what to do, which takes a while. It's actually beautiful to see. So let's go, let's go. Don't tell me it's going to win. Oh, okay. He can't be sure, but there's no mines left. So we won, basically. Everything else is a mine. Let's just press here. Oh yeah, we won. Here it is. So, bad one, bad example. Let me just come here. If I change this to basic, it will be faster. Something went wrong. Let me go again. Okay, okay. Okay, it played well again. Yeah, we won. So in some cases, it doesn't know what to do and it reaches a stalemate, and then we need to guess. Let me just try again to see if that shows. Yep. So this is how you use, well, I'm having bad luck, but you guys can try it. I'm going to share this code on GitHub. So here you go, how to create an AI that solves Minesweeper using linear programming. Hope you guys enjoy this.